Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 18 of our chapter P block elements, we are going to discuss chemical properties of group 17 elements. That is part 3. In previous video we have seen many of the students have not watched 10, 11, 12 videos. Okay, so please watch that video so it will be easier for you to understand various topics, because there is a test, MCQ test, what we say. So please read. Okay, go through the videos, previous video, then this will be easier to understand. Now, in this chemical properties of group 17 elements, we are going to discuss about reactivity of halogen towards oxygen, right? Now, halogen forms many oxides, and we say that is fluorine, chlorine, bromine, iodine. No? So fluorine form only 2 oxides, while other halogen, that is chlorine, bromine, iodine, they form many oxides, but they are all unstable. Clear? So I can write down this point, that is halogen forms many oxides, but they are unstable. Clear? Now, when we talk about fluorine form only 2 oxides. Fluorine form 2 oxides. Clear? Now, which are their oxides? Now, fluorine, when we say, it is the most electronegative element, and it forms both 2 oxides, OF2 and O2F2, what we call it as. These are the 2 oxides which are formed by fluorine. Right? Now, in this case, when we say fluorine is the most electronegative element. Clear? So its oxidation number is -1. Right? So if fluorine is having -1 oxidation number, here -1 means -1 into 2 means -2. So oxygen in this case will have +2 oxidation number. Understood? So don't forget this thing, okay? And these compounds are called oxygen fluorides, what we say. Means fluoride word is used as last because it is the most electronegative element. Understood this part? Now here in this case also, here if you see -1 into 2, so 2 into -1, so +1 into 2, that is +1 is the oxidation state of this oxygen, and here +2. Understood? So because fluorine is the most electronegative, oxygen comes second according to Pauling scale. Which scale? Pauling scale, where oxygen comes second. Now, since fluorine is the most electronegative element, you will see here it is having -1 oxidation state. It will not leave its oxidation state. Okay. Now, certain names are there which you have to remember. Since fluorine is most electronegative, what I have written here, you can see, then oxygen, those should be called oxygen fluoride and not fluoride or fluorine oxides. Clear? So, as you can write here, as fluorine is the most electronegative or electronegative than oxygen, it should be called here. Now what it should be called? So it should be called, what we call it as oxygen fluoride. What is the word? Oxygen fluoride. Means fluoride is written at the end, and not what we call it as, fluorine oxides. It should not be called as fluorine oxides, because electronegativity is given more preference in the parent name, what we call. Now this part I think understood. Okay. Now when we talk about this, formula should be written as, and this is the word you understood, and this formula should be written as. Now when we say the formula should be written as OF2 and O2F2, and not what we call it as, because in that case, and not F2O and F2O2. don't write the formula like this, otherwise it is wrong what we say according to the IUPAC nomenclature, and this electronegative part what you have seen from the beginning. Okay, so remember this thing. Now this was all about what we call it as fluorine. Now when we talk about the next part, that is this both, what we say, both OF2 and O2F2 are fluorinating agent. Which agent? Fluorinating agents. Understood? Now this you have to remember. This is asked in MCQ. Now O2F2. Now when we talk about the radioactive part, so O2F2 can oxidize. What is the word? Can oxidize plutonium to PuF6. To PuF6, which O2F2 is used in what you call it as nuclear reactors, nuclear chemistry. What we say, O2F2 can oxidize plutonium to PuF6. Therefore, O2F2 is used. O2F2 is used, what we call it as, to remove the remaining, what we say, to remove plutonium as PuF6 from what we call it as spent nuclear fuel. Clear? Means the nuclear fuel which is once what you call used up. No? From that, if you want to remove plutonium as PuF6, you need to use what? O2F2. Okay, so this can be asked in MCQ also. Understood? So remember this thing, this all part. Okay, this was all about fluorine. Now remaining what we call it as of halogen, how they form oxides, that I will discuss. Just a minute. Okay, now when we say about the another part, that is decreasing order of the stability, we can write down Cl, Br and I minus. I think point number 4. Cl, Br and I minus and I, sorry, not I minus, and I, what we call it is in decreasing order of stability in oxides. Okay, it is this halogen when they form oxides, no, its decreasing order is written. That is the stability of oxide. Stability of oxides. You can write. Now there can be I minus I, iodine oxide is more, and chlorine, and then comes bromine. Understood? So here I am writing iodine oxide. Understood this part? Not what we call it as oxide iodide like that, oxygen iodide like that. Understood? Because these are less electronegative than oxygen. Oxygen electronegativity is 3.5. Fluorine electronegativity is 4.0. So second number comes of oxygen. So oxides, like when we write, you have to remember our iodine. Understood? Now, when we talk about this, the most what we call stability, that is iodine, then comes bromine, and then comes iodine. Sorry. First is iodine, then chlorine, and then bromine. The oxidation state of what we call it as Cl, Br or I is positive in their oxides. Understood? Means if I write like this, suppose one oxide in your book they have, I think, given there, you can see I2O4. Understood? So in this case oxygen will have negative oxidation number. Understood? While this one will have positive oxidation number. Understood? You clear? This part clear? Okay, so this was all about I2O4. Now, like this means oxide in which halogen will have positive oxidation number, what we say. Now, when we talk about the oxides of chlorine, now we are talking about oxides of chlorine, because in that all are given one by one. Now, in oxide of chlorine, the chlorine form many oxides, but they are highly reactive oxidizing agent and tend to explode. Now, chlorine forms, we can write chlorine forms oxides. Now, which are that oxides that chlorine forms? You can write it down. So, you can see also in your textbook. Cl2O, then ClO2, Cl2O6 and Cl2O7. Clear? Now, these are highly reactive, what we say? These are highly reactive oxidizing agents, and they explode also. So you have to be very careful when you deal with this. Understood this part? Okay. Now, in this case, out of this ClO2 is used as bleaching agent. What is it used as? Bleaching agent. So in a paper industry, that pulp is yellowish color. So to make it white color, this one is used as bleaching agent. You can write down this as MCQ also. Okay, it is used as a bleaching agent. Okay, for paper, pulp and textile and in water treatment. Paper, pulp, textile and water treatment. Understood? Now, what is the meaning of this? That is, when we say the wood pulp, the wood, soft wood trees are there and they are being crushed, and yellow color pulp we get. Now, that pulp, what they do, they use this bleaching agent to make that pulp white, because of paper, what we say, it is pure white, like this board, what we say, to make it pure white. Same way textile, when we say the clothes, clear? They have a yellowish color tint. So to remove that, they use this as bleaching agent. Second thing, water treatment. Sometimes some places water are of colored form, or from industries when waters are being thrown out as an effluents, they are in colored form. So they have to be what we call treated, and for that, cleaning that water and making it white, they use for water treatment, they use ClO2. Understood this part? Now the next one we'll talk about bromine oxides. Okay. Now I will rub this. Now next one will be your point number 6, what we said. Oxides of bromine that we'll discuss. So the next one is oxides of bromine. Okay. Now point number 6. Now, when we talk about oxides of bromine, bromine oxides are, which are formed, bromine oxides are. Now, which are there? So, in your textbook, you can see Br2O, Br2, and the last one oxide what is formed is BrO3. Clear? Okay. Now, these are the 3 oxides which are form of bromine, what we say. They are strong or powerful, you can write, powerful oxidizing agents, because, what is the reason? Because they have very low thermal stability and easily release oxygen at high temperature. They easily release oxygen at high temperature. Understood? So this was about that. Then point number 7. So this is all about bromine, what we have discussed. Then we have discussed chlorine. Then we have discussed iodine. I think Oxides of iodine are left, I think that we'll discuss. Now we'll discuss about oxides of iodine. Clear? Now when we talk about this oxides of iodine, iodine forms the oxide, what we say, no, are I2O4, I2O5 and BrO3, sorry, and I2O7 oxides. Iodine form this many oxides, what we say. Understood? Now in this only, I2O5 can oxidize CO, that is carbon monoxide, to carbon dioxide. Understood? So this is the reason exhaustively, and therefore exhaustively means even the last CO will be converted to CO2. Understood? Exhaustively, and therefore I2O5, what we call it is I2O5 is what we call it as used in. This one can be asked in MCQ. MCQ. I2O5 can be used in what we call it as estimation of carbon monoxide. Okay, so if you want to estimate carbon monoxide in air also, you can use this, because carbon monoxide is a poisonous gas. To estimate that, in environmental chemistry they use I2O5 to oxidize CO to CO2. So how much CO will be used, that can be estimated carbon monoxide. Okay, now the next one, I think this part is over of all oxides, what we say. Now we will discuss the next one, that is about metals, that is reactivity towards metal. I'll drop this part. Now this reactivity of oxygen is over in this video. Now we'll discuss about reactivity, what we call it as, towards metals. Now this is on same page number what we are discussing about. Now in this case, when we write the halides of alkali metal in decreasing order of ionic character, halides of alkali metals in decreasing order, alkali metals in decreasing order, what we call it as, of ionic character. Clear? Now in this case, when we say halides, MF is there greater than MCl is greater than MBr and greater than Mi. Clear? Now this one, what we say, is the most ionic in nature. Clear? Means MF means metal fluoride, or alkali, what we say, sodium fluoride and all, what we say. Okay. The most ionic is this MF, what we say, and the least ionic is Mi. Least ionic is Mi. Understood this part? Now the second part, what we say, in this metal only, one question can be asked in that metal part, what we say. Okay, now here one topic is there, halogen react with metal to form metal halide. For example, metal halide, when we say one bromine reacts with magnesium to give magnesium bromide. What is the word? Bromine reacts with magnesium to give magnesium bromide. Okay, bromine reacts with magnesium to give magnesium bromide. The reaction you can see given on 202 page, that is Mg, that is a solid, plus Br2, what we say, it's a liquid, Br2 bromine, to give you what? MgBr2. Understood? So out of this, when we say this one comes at the third place in the ionic character, decreasing order. Understood? Most ionic is this, least ionic is this comes on second number, this MgBr2. Okay, so this was all about metal what we have seen here. Then the next one, which is say about many things are given there in your book. Okay, we will see one another part. Instead of this, I'll just write this. I'll write one question can be asked, so that we will write here. Okay. Now one question can be asked. This is the most important question. Remember this thing in this metallic part only. That is which is more covalent, SnCl2 or SnCl4? Which is more covalent, SnCl2 or SnCl4? Okay, this is the question which is asked frequently. SnCl4. Okay, the reason when we write, we can write the answer here as oxidation state of metal increases covalent character also increases. Understood? So this is the most important. Oxidation state of metal increases, covalent character increases. Now in SnCl2, what we say, oxidation state. Okay, you can see here the oxidation state of SnCl2. In SnCl2, Sn is +2, and in SnCl4, oxidation state of Sn is, what we say, you can calculate here. See, -1 into 4, so it will be what? +4. So what we have said here, as the oxidation state of metal increases, covalent character increases. So who is more covalent? Obviously this one. So therefore you can write therefore SnCl4 is more covalent than SnCl2. Okay, so this part is clear what we say. Now in the same way, you can see in your textbook PCl4, SbCl5 and UF6. Clear? Now in this what we say, you have to see the oxidation state of metal. Okay, so it will be clear. Okay, so in this are more covalent than what you call it as PCl2, SbCl3 and UF4 respectively. Understood? So this was all about what we call it as metals, what we have discussed, that is reactivity towards metal. Now the third part what we are going to discuss is about reactivity of halogen towards other halogen. Okay, so I will rub this part. This question you can write down in your fair book. Okay, so it will be easier for you to learn during exam. Now the next one what I am going to discuss, there is the third reactivity. Reactivity of halogen towards other halogen. Now when we talk about in this case, that is interhalogen compounds we are going to talk about. Which compound? Interhalogen compounds. Clear? We are going to talk about interhalogen compounds, what we say. Understood? So now in this case when we say halogen combine among themselves to form a number of compounds known as interhalogen. So these interhalogen compounds what is are of the form X, X dash, X, X dash 3, X, X dash 5 and what we call it as X, X dash 7. Okay, so +1, +3, +5 and +7 oxidation state compounds I am talking about. Now in this there is one difference. You can see one is X and another is X dash. Now in which what you can see where X, what we say, is a larger size atom, halogen atom. Understood? And X dash is what we call it as a smaller size halogen atom. Okay, so these are the interhalogens what we are talking about. Now these interhalogen compounds are given in your textbook on page number 206. This interhalogen, page 206. A table is there. Table 7.11. Clear? So there you can see many interhalogen compound. So now suppose if I want to give an example of this XX dash, what is there? You can write for XX dash CLF. What is the word? CLF. So F is the smaller size atom and this is the bigger size atom. Okay, here I can write CLF3. Understood what you say? Or another one if you want, I will write ICL3. ICL3. Understood? So iodine is bigger and Cl is a smaller atom. Understood? Then for this I can write down BRF6 or BRF5, sorry. Okay, there is another one, last one, that is IF7. So these are the example of interhalogen compound that you will study. I think it is not there in your what you call course. It has been cancelled in this year. That is March to May 2021 board exam. It is being cancelled. Okay, so we will not be discussing that now. In our what you call it as the next video, we will be discussing about chlorine preparation, properties and uses, what we say in our next video. That's why we extended this video and what you call completed all the reactivity. That is 3 reactivity we have seen. Reactivity towards what you call it as oxygen, towards metal and towards other halogen. Okay, now from reactivity towards oxygen there are many questions which can be asked, so it is your duty to go through it. From the textbook also read thoroughly. Previous videos please see properly, because most of the students are not watching previous videos, right? So there will be difficulty to understand. So in the next video we'll be continuing with the chlorine, bromine and iodine part. Chlorine preparation, properties and uses, what we say. Okay, then I think oxides of halogen is one topic, and what we call it as last topic, that is group 18 elements we will discuss, and I think our chapter will get over after this. Okay, so this was all about what we say in our video number 18. Please go through it. It is the lengthiest video till now, so have patience and watch. Okay, thank you very much.